Hello everyone. Today we'll be doing the experiment on preparation of triphenylmethanol. These are the lab materials for the experiment that we will need. This experiment is extremely sensitive to the presence of water or moisture, even that in the glassware. So all the glassware used in this experiment must be baked dry using an oven. So by glassware, I mean just the glass parts, and you should not be baking the plastic things in the oven since they will melt. So we are going to take all the glass parts, such as the Erlenmeyer flask, the vial, the drying tube, the Claisen head, the round bottom flask, etc., and we will place them in the oven for 24 hours before starting this experiment. So this is all the glassware that was in the beaker, placed in the oven at 120 degrees Celsius for 24 hours, and we are taking it out. And now we know it's all devoid of water. First thing we will do is to set up the drying tube. We will set it up by filling it partly by cotton and partly by calcium chloride. The calcium chloride works as a desiccant and prevents water from getting into the reaction mixture. Next is to measure or dispense out 20 ml of diethyl ether using a syringe that is definitely devoid of any kind of moisture or water. Since we do not want any water molecules to get into our system, we need to cap all containers almost immediately. Then we measure out about 0.15 grams of magnesium turnings to add to our reaction mixture. The final mass of magnesium turnings taken is 0.1544 grams. Coming back to our fume hood, the aluminium block is placed on the hot plate and the magnesium turnings are transferred to the round bottom flask, and the flask sits snugly on the aluminium block. Then we will weight out a reaction vial which will be used for transferring bromobenzene. The mass of the bromobenzene reaction vial is 25.9955 grams. Next is to pipette out 0.7 ml of bromobenzene into the vial. We do this by using a mechanical pipette. We then cap the vial and the reagent bottle. Then we take the mass of the reaction vial with the 0.7 ml of bromobenzene in it. The mass of vial plus bromobenzene is 27.3890 grams. Next is to measure out 4 ml of diethyl ether using a syringe. This 4 ml of diethyl ether will then be transferred to the reaction vial containing bromobenzene. Then the spin bar is put inside the round bottom flask and the setup is arranged as shown. At this point, the reaction setup is ready. Next step is to syringe out 1 ml of reaction mixture into the round bottom flask. The mixture is drawn into the syringe without opening the cap as shown. That's 1 ml. Now we are pushing the plunger down and the reaction mixture goes into the round bottom flask. After switching on the heat and magnetic stirrer, the solution starts to bubble and it has started to reflux. We wait in this stage until the magnesium dissolves. However, if the reaction does not start soon enough, the flask needs to be held in the palm of your hand and the Mg turnings need to be crushed. This is in order to remove the MgO or magnesium oxide. We didn't need to do this in our case since the reaction has started to bubble. Five minutes later, the reaction is bubbling gently, and this is when we add the rest of the reaction mixture. Then, after putting the rest of the solution, we rinse the vial with about 1 ml of diethyl ether and add the rinse to the reaction mixture using a syringe as shown. At this stage, the reaction mixture will be left to reflux for 15 minutes. After about 15 minutes, when all the magnesium dissolves, we switch off the heat, remove the aluminum block, and kind of elevate the round bottom flask by adjusting the clamp to take it away from the heat source. The magnetic stirrer is still on though, so the reaction should go on without heat. During this time, we get our reagent ready. The reagent, which needs to be an aldehyde or ketone, is made by dissolving benzophenone in diethyl ether. The TA weighs out about 1.09 grams of benzophenone and transfers it into the reaction vial containing 2 ml diethyl ether. This will be added to our Grignard reagent. This vial has also been dried in the oven for 24 hours. When the round bottom flask has cooled down, so that is about 5 minutes after we switch off the heat, 5 to 10 minutes, that's when we add the benzophenone dissolved in diethyl ether. We need to note the color of the solution at this point and how it is going to change after the addition of benzophenone. The benzophenone must be added when the solution has cooled down completely. The addition of benzophenone needs to take place very slowly. So very slowly, we push the plunger down. And notice the color change.
When we finish adding the benzophenone, as we have added it very slowly, we will see a white precipitate form in the flask. We will be working with this solid in the next laboratory period.
So hello again, everyone. When we come back in the next laboratory period, this is what the round bottom flask looks like. As we can see, whatever we had left yesterday, it was in the solution. Now it has dried to a solid. Next, we add 6 ml of HCl slowly into the round bottom flask. So this needs to be done very slowly. The 6 ml HCl is supposed to dissolve all the non-organic contents in the round bottom flask. Next, we also add some ether from the Arlen-Mara flask to dissolve everything. And we will see 2 layers form in the round bottom flask. One is the aqueous layer and one is the organic layer. Then after the addition of the ether and the hydrochloric acid, we keep the round bottom flask on the hot plate but with the heat off and the manual stirrer on. This step is done in order to ensure everything dissolves before the extraction step. This is the separatory funnel that will be used for extraction, and we have made sure that neither the separatory funnel nor the beaker underneath contains any water by first cleaning the apparatus with acetone and then air drying it profusely. When the solids dissolve and we are able to see 2 different layers, that's when we take the round bottom flask off the hot plate. The upper layer is the organic layer and the bottom layer is the aqueous layer. We have to then remove the stir bar. Then we transfer the contents of the round bottom flask into a separatory funnel. Also make sure that the bottom tap is closed. Use extra ether to rinse the round bottom flask and transfer the rinse into the separatory funnel. Then we close the separatory funnel from the top and then shake the separatory funnel and release the gas that is produced as shown in the video. Continue doing this until you no longer hear a hiss from the gas. Then you let the separatory funnel sit at rest for a few minutes until the layers separate completely, the aqueous layer and the organic layer. As we can see, the aqueous layer and the organic layers have separated. And the aqueous layer is the one at the bottom and the organic layer is one at the top. Since it's most feasible for us to collect the aqueous layer first, we set the beaker labeled aqueous underneath the separatory funnel. When we need to drain liquids from the separatory funnel, the first thing to do is to remove the top of the separatory funnel as shown in the video. Then we carefully open the tap at the bottom. You can see the solution draining bit by bit. And we need to carefully control the flow since the funnel runs very quickly. We close the tap when all the aqueous layer has run and set the beaker aside. Then we place the beaker labeled organic below the funnel and open the tab again. As can be seen, we don't need to be as careful this time because the organic layer is the only solution that remains in the separatory funnel. Next, we are going to add more ether in the aqueous layer in order to extract more of the organic compound. So this aqueous layer with more ether will go back to the separatory funnel and we will have to do the extraction once again. Once again, shake, shake, shake. Open the tap to release the gas. And continue this until you no longer hear the hiss. Then invert the funnel and place it back into the clamp. So this is how the two layers have separated. Once again, you collect the aqueous layer first. After letting the mixture rest in the separatory funnel for about 2 minutes or so, we once again take off the cap at the top of the funnel and slowly and carefully open the tap at the bottom to drain the mixture. Once again, we collect the aqueous and organic layer separately. Whatever we need is in the ether layer, so we remove the organic beaker and preserve the ether layer by using a parafilm to seal. Then we will add drying agent to the organic layer to extract the water out of it.
Here is the drying agent, sodium sulfate, that comes in the form of a powder. We are going to add the drying agent until it no longer clumps.
Once again, we are covering it since the ether evaporates very rapidly. After letting the organic solution rest for 15 minutes, we are going to use a pipette to transfer the solution from the organic beaker to a fresh clean beaker. We are going to do this carefully using a pipette to make sure that none of the drying agent gets transferred to the other beaker. This step is done to separate the solution from the drying agent. Then we will subject the solution to air evaporation by blowing air from the tap in the hood. After evaporating the ether by blowing air, we will get the oily product. Our next step is to add petroleum ether to remove the byproduct, which is biphenyl.
Upon addition of petroleum ether, we stir and swirl this product as much as possible in order to dissolve it all.
Here is adding 3 ml of petroleum ether to dissolve the product on the walls of the beaker, and then we will be subjecting it to heat. When all the product seems to be sufficiently come in contact with the ether, we subject the mixture to vacuum filtration.
The TA is scraping the beaker to make sure that all the solids get transferred to the harsh funnel.
Then we use more petroleum ether to rinse the beaker and wash the product.
And let the product dry completely in vacuum.
After the product has been subjected to vacuum drying for about 10 minutes, we transfer the product into a beaker and this product will be subjected to recrystallization. We will be using isopropanol for the recrystallization. This clip shows what the product looks like when it just dissolves in enough amount of solvent, in this case isopropanol. The beaker containing the product is the one on the left hand side. As you can see, this is what the solution should look like when enough isopropanol is used to just dissolve the product. It will then transfer into an ice bath. After cooling down in the ice bath, as you can see, there has been enough crystals formed, so we are going to vacuum filter it. And same thing, we are going to use cold isopropanol in order to rinse the beaker and wash the product. Then the product will be dried in vacuum for 5 minutes, during which we can weigh out an empty vial. Mass of the empty vial and cap is 9.8914 grams. After drying in vacuum for about 5 minutes, we transfer the product into a product vial. Now that we have obtained the triphenylmethanol product, we need to do characterization. For characterization, we need to take the readings shown in this slide. Mass of the product, IR, and melting point. Mass of the vial plus cap with the product was measured to be 10.3340 grams. Next step is to collect the IR of the product. Once again, first thing is to clean the stage using isopropanol or methanol and clean the stage very well and then wait for the stage to dry.
Collect the background and then
The
load.
sample so that the peephole is covered. Cover the sample with a piece of paper. Turn the handle and then screw the knob until it's tight. Collect sample, click yes. Then wait for 8 rounds to finish. And then add to a new window yes. Click on find peaks. Adjust the horizontal lines to cover all the peaks. Click on print.
Our next job is to take the melting point. So we are going to take some of the sample into a melting point tube. Then we insert the melting point tube filled with 2 to 3 millimeter of the substance, maybe around 3 to 4 millimeter of the substance inside the melting point instrument. And then we put the tube inside the instrument and we run the instrument very fast until it hits close to the literature value. When the temperature of the instrument is close to the melting point value that we have found in our literature sources, we reduce the speed of the instrument down to like 1.5 degrees Celsius per minute. and that's the increments it's gonna go. So it's gonna be very slow from now. So the sample has started to melt. And now the sample has finished melting. So we have collected the readings that will be required to calculate the mass of the product. We have collected the IR and we have collected the melting point. That concludes our experiment. Finally, before leaving the lab, you need to clean your workstation and your bench. So everything needs to be cleaned and put into place. And the hot plate should be devoid of anything on it. And all the glassware that we use needs to be cleaned first with acetone and then with water, and it needs to go into the liquid waste. And all the even the weight, the place where you took the weight, that needs to be cleaned. And then the place where we took the IR, that hopefully has been cleaned by isopropanol or methanol. So everything, it should be clean of all substances that you put on it. And the melting point tube needs to go into the glass waste. And any kind of broken glass also needs to the glass waste. And you put the solid waste beaker on the side, as you see. So that's it, guys. Thanks. Have a great day.